This is the first extension we're going to look at. So we're going to look at how do we find the square root of a binomial that contains a square root. So let's say that this is equal to x, okay? And we want to find x, but we want to write x as in this form, okay? So we want to simplify this. This is kind of difficult to comprehend. We can make it look a lot nicer with a plus b squared of 2, where a and b are going to be integers, okay? So whole numbers. Okay, so we can start by squaring both sides, or all sides, if you will. So when we square a square root, this is going to cancel, right? We've got 11 minus 6 squared of 2, our giant square root's going to cancel. That's going to be equal to x squared. And remember, x is what we're trying to find. And x is this binomial here. And so we can square that. Remember, squaring it's going to be just multiplying it by itself. So foiling it. Okay, so 11 minus 6 squared of 2. We know that's equal to x squared. We know we're trying to find x. Which is just a plus b squared of 2. So we'll just focus on a and b for now. So when we FOIL this, we've got a squared plus ab squared of 2 plus ab squared of 2 plus b squared times 2, right? The square root of 2 times the square root of 2 gives us the number 2. Okay, so when we simplify that, we've got a squared plus 2b squared, right? Those are the two without the square root of 2 in them. And then we have 2ab squared of 2, right? So now we can start to equate both sides of the equation so we can find what a and b are. And remember, we said a and b have to be whole numbers. Okay, so we know that these don't have square roots of 2 in them. So 11 is going to be equal to a squared plus 2b squared. Okay, and then this negative 6, that coefficient, is going to be equal to this coefficient. So negative 6 equals 2ab. Okay, so we can divide both sides by 2 pretty easily here. We've got negative 3 equals a times b. Okay, we could use algebra here, but honestly, it involves working with a quadratic. Instead, I'd like you to just think about this. So we said a and b have to be whole numbers. So to get negative 3, we're going to have 3 times negative 1, or 1 times negative 3, or some combination of that, right? We could have negative 3 times a positive 1, whatever. So a and b would have to be one of those things, right? Okay, so those are our 4 combinations. Notice this hint up here. It's actually not that great of a hint. What would be a better hint is the fact that the square, essentially we're taking the square root of this here, right? So we made x squared. So if we take the square root of x squared, we can't be taking the square root of a negative. Okay, so whatever a plus b squared of 2 is, we don't want it to be negative because we're dealing with square roots. Okay, so if you think about it, if we use a negative 3 for our a, so if we do negative 3 plus 1 square root of 2, that's going to give us a negative, right? The square root of 2 is about 1.414 something. So that'll give us a negative number. So we can't use that one. Okay, and same with this, this one down here. We won't be able to use that if we do, oh no, that could still work actually. Okay, so we've eliminated 1. Okay, so negative 1. Okay, and then it's just your job to try and work through, okay, what could my possibilities be? So we're left with these 3 choices. Okay, now we've got this other equation over here, and we just have to plug them in and see what's going to work, what's going to give us 11. So if we do 3 squared plus 2 times negative 1 squared, that's this first combination. Do we get 11? Well, we've got 9. Remember, a negative 1 in brackets squared is a positive 1, right? So, because a negative times a negative is a positive, of course. So we've got 2 plus 9. Yes, that is 11. So we end up with A is 3 and B is negative 1. And if you try either of these two combinations, you'll find that they don't work in this equation. Okay, so what does that mean? It means that the square root of 11 minus 6 square roots of 2 is equal to x, remember? And x was A plus B square roots of 2. Okay, and we just found out that A is 3 and B is negative 1. So we can say this is equal, this giant square root is equal to 3 minus the square root of 2, which is a much nicer way of presenting it. And you can always check this. So if we square both sides, so we square this, and if we square this, we're getting rid of that square root, right? And then we should have, if we square this, we should have multiplied by itself. We have 9 minus 6 square roots of 2 plus 2. So that gives us 11 minus 6 square roots of 2. And that is exactly what we're looking for.